Hi guys, my name is Juan and I'm from Team Pressure. Today I will explain one of the simple topics in Engineering Mechanics 1, which is Coplanar for System. What is Coplanar for System? Let us look into its definition. Coplanar for system is the line of action of all forces lie in a common plane. To get a clearer view, let us look at this diagram. It can be seen that a particle which lies in y and x plane is subjected by a system of coplanar forces, which I denoted them as F1, F2, F3, and F4. Because of the forces acted on the particle by the various angles, each forces can be resolved into I and J component. In a state of equilibrium, these forces must sum to produce a zero resultant force, which are shown by this equation. For this vector equation to be satisfied, the forces x and y component must be equal to 0. Hence, sum of forces in x component is equal to 0, while in y component, the sum of forces also is equal to 0. These two equations can be solved for at most two unknowns, generally represented by angles and magnitudes of forces shown on the particle in the free body diagram. One of the important things that you need to know is the sign convention of the direction of force. Components are positive if they are directed along a positive axis, while negative if they are directed along the negative axis. For example, consider the free body diagram of the particle subjected to the two forces as shown in this diagram. Here, it is assumed that the unknown force F acts to the right in order to maintain equilibrium. By applying the equation of equilibrium along the x-axis, we have the summation of force in x-axis equal to 0. Therefore, we have the positive the unknown F plus with the positive 10 Newton equals to 0. Both terms are positive since both forces acts in the positive x direction. When this equation is solved, we will get the value of F, which is negative 10 Newton. Here, negative sign indicates that F must act to the left to hold the particle in equilibrium. Meanwhile, if the positive x-axis were directed to the left, then both terms would be negative. But again, after solving, F is still equal to negative 10 Newton, indicating that F would be directed to the left. Now, let us do some exercises. Here is the diagram of question 1. In this question, it wants us to find the tension in cable BA and BC in order to support the 60 kg cylinder. Some information has been given in the diagram. So, when you got this question, the first thing that you need to do is to identify all the forces acting on the body by making free body diagram. This is the free body diagram that I have drawn. Due to the equilibrium, the weight of the cylinder causes the tension in cable BD to be TBD equals to 60 times by 9.81, which gives the value of 588.6 Newton. The forces in cable BA and BC can be determined by investigating the equilibrium of ring B. Let us look to the second free body diagram. It looks like the magnitude of TA and TC are unknown, but we know their direction. So, the next step is applying the equation of equilibrium along the x and y axis. Now, we have the summation of forces in x-axis is equal to 0. Therefore, by using trigonometry, we will have our first equation, which is TBC cos 45 minus 4 over 5 TBA equals to 0. Same goes to the y-axis. We will have our summation of forces in y-axis as our second equation. Next, from equation 1, we can make TBA equals to 0.8839 TBC. Then, we substitute this equation into the second equation. Thus, we can solve the unknown and we get the value of TBC is equal to 476 Newton, and we have TBA is equal to 420 Newton. Now, let us look to the second question. In this question, we can see that 200 kg crate is suspended using the rope AB and AC. Each rope can withstand a maximum force of 10 kN before it breaks. Here, AB always remains horizontal, so we want to determine the smallest angle theta that the crate can be suspended before one of the rope breaks. Now, as usual, the first step that we need to do is to draw a free body diagram. In this free body diagram, we will study the equilibrium of ring A. There are three forces acting on it, which are FC, FB, and FD. By looking at this free body diagram, we can get the value of FD. We know that the maximum force that a rope can withstand is 10 kN. Therefore, we can see that the rope AD will not break as its tension force is less than 10 kN. The next step is we apply the equation of equilibrium in the x and y axis. We will have two equations, the first equation and the second equation. From equation 1, we can see that FC will be greater than FB since cos theta is less than 1. Therefore, rope AC will reach the maximum tensile force of 10 kN before rope AB. By substituting the value of FC into equation 2, we will get the smallest value of theta, which is 11.31 degrees. After knowing this angle, we can find the value of FB, which is 9.81 kN. Now, we have done two questions. Now, I would like to summarize what we have learned today. In dealing with the problems related to coplanar force system, the first step that you need to do is to identify all forces acting on the body by making free body diagram. Be careful with the sign convention of the direction of forces acted along the axis. The second step is you apply the equation of equilibrium, which are presented by these two equations. Then the final step is you solve the equation in order to get the unknown. The reference book that I have used for this video is Alston Hibler Engineering Mechanics Statics 12th edition in SI units. I think that's all from me. Thank you.